Well, there's a massive list of firsts on this building. When we were going through the whole process with AWS, the whole thermally broken large shop front glazing hadn't been implemented yet anywhere. So we were essentially the first to design it and one of the first to be built in Australia with the full height shop front glazing with a ThermalHEART product. Well, the Flannery Centre is a college where we teach and train apprentices to build ecologically. The client very early on wanted to take on as many sustainable building techniques as they could to prove that it doesn't cost a significant amount more than the standard building, and I think that actually has been achieved. I mean, it's creating its own energy, they're putting power back into the grid, they don't have to turn the lights on. During the day, everything has natural daylight flooding through the space. We're anticipating a 6-star Green Star building. The building itself is designed around a main hub. The entry and the gallery peel off on either side, and then from those secondary circulation gallery spaces are all the teaching and administration spaces. The construction of the Flannery Centre is essentially a thermally broken frame, if you like, with a brick veneer construction around it. The builders on site actually refer to it as an esky. In our main spine down the middle of the building, on the gallery space, we actually allow the sunlight in winter to come all the way through and hit a rammed earth wall, which is 300 thick, that runs the full length of the building. And that way during the day it warms up, and at night it re-radiates that heat out into the space. So we get a very temperature consistent building, and the glazing helps us do that. With the glazing, there were several things. One was obviously the thermal bridging that you get through standard frames, not only on small windows but large windows. There are several products out there that enable us to do that with the smaller windows, but that didn't really suit us. The hub is such a central part, we had to have the same glazing suite across the board. When it came to doing the large window frames, there was no one else out there who was providing this type of product on the market without actually going through the process of a bespoke or a custom-made section. Here was something that was fresh onto the market, met all our requirements and was readily available. So it was a no-brainer at the end of the day. We had some environmental consultants on the project, and they started to push us down the path of a timber frame. Apart from the environmental thing, I like to think that we could be designing maintenance-free buildings. If you can put it up and you never have to touch it, then all the better. With a timber frame, every so often you're going to have to repaint it and it gets a bit old. So when we discovered that we could get the same sort of thermal performance out of the aluminium section, that was the big winner for us. I'm a fan of a nice chunky section, and this came in good pieces. Because it's a thermally broken frame, you can actually powder coat one side one colour and one side the other colour. We did at the end of the day. Powder coated it on one side and we left it anodised on the other side. Another part of the whole Green Star thing is you should be using locally available products. Why would we source a material from Europe when there's a company providing it for us here? The technical data that AWS provided was invaluable in the project. For them to be able to provide us very quickly DWG files, or files that we can drop straight into AutoCAD, or that can then allow us to manipulate other materials around it so we can see it and how it works and how everything's flashed and sealed is great. Although the building's been open since February, one of the biggest responses was from the builders who are actually building the site. They said that working internally was extremely comfortable. It could have been 40 one day and 4 the next day, and they were inside just in their shorts and shirts and their high-vis vests, and they said it was an extremely comfortable environment to work in. Why would you go back to a non-thermally broken frame? I mean, the technology is out there, we should be using it.